Hi,
Yes.
my name is Brian, and I am interviewing Eugenio Culurciello.
Nice to meet you, Brian. Thank you for the interview.
Yeah, yeah. So, can you explain your background?
Yes, yes, sir. So I was actually trained on um, analog and mixed signal microchip design, and I work in neuromorphic engineering area at the beginning. So the idea was to figure out uh, how to replicate human abilities in silicon or in artificial technologies. And then I later I started working on machine learning and neural networks when I met Jan LeCun. I was at Yale University and he was at NYU. And then we met and we started working together. First, we started developing some microchip accelerators for deep learning.
Mhm.
That was like about 15 years ago. Yeah, it's and yeah, this area was not really popular.
Oh,
And
okay.
then when I joined Purdue in 2011, like I continue my group developed about five generation of machine learning hardware, but we were also developing neural networks, models, and like my group has been also instrumental in like the beginning of PyTorch, Torch, which was the precursor of PyTorch. Um, so yeah, we worked on all this area, and right now I'm a professor at Purdue, and I work on machine learning and AI, and I try to work on multimodal large model at the moment.
Okay. I also saw that you taught some deep learning courses here.
Oh, absolutely, yeah. Actually, ours was the very first deep learning course at Purdue. We started 2011, 12,
Hmm.
and uh, and it was early days. And yes, we've been teaching deep learning ever since, at least once a
Yeah.
year.
I was actually interested, like, how come the deep learning courses were taught under like BME instead of like CS or like if I
Oh, absolutely. Yeah, I was hired in BME because a lot of our work was like taking inspiration from biology, neuroscience, and psychology. And but the final goal was like replicating the human brain in hardware and software. And then when I joined here, yeah, there was a few people teaching neural networks, basic fundamentals, but we were really the first class to teach the more modern deep learning, including convolutional neural network and so forth. Yeah.
understand. Okay, so I wanted to ask you about this paper I saw last year. The paper was
Yeah.
called Fish Brain, and it's where researchers they like grew brain cells and then they teach
Yeah.
it to play the video game like Pong. So I thought because
Yeah.
you have a lot of experience in hardware, I was wondering whether this is a plausible idea in the future where you use like real brain chips and then these chips are specifically trained for certain tasks.
I think it would be a good idea also because like currently all the machine learning hardware that we built is highly inefficient compared to the brain, like on the order of 1,000 to 10,000 times less efficient. And so like if you could interface to living and breathing live neural networks, um, that would be awesome. One of the issues there is that like we currently don't have the capability to really interface at a very large number of cells or high throughput. So the input and output is a bit limited. Um, but that said, yeah, I think it's could be very promising area if we can figure out a way to grow the right number of electrode to interface with the tissue.
Mhm. Okay. So it might be hard to like add a like image sensor or something like directly to this brain chip, I guess.
Yeah, I think that the problem is the number of in the brain, like maybe in a millimeter cube, you have hundreds of thousands of cells, right? But in terms of like a physical connection, um, we couldn't have that many, right? There's probably a million of connection in there, but we can have the right, the very large number of connection. Also, all the connection that we have with from computers to biology is like using some kind of electrical wires, and they usually living cells don't usually like that. They reject it, and um, that's also a problem for wearable technology that are invasive, and it's always been a bit of a problem, and I don't really know how to solve it. At the moment, but there's many colleagues here at Purdue that work in that area also.
Okay. My next question. So,
Yeah.
um, what do you think about the embodied Turing test, where instead of judging an AI based on how it can mimic human intelligence, you judge it based on how good it is at doing certain like animal related tasks? So, for example, an artificial beaver building a realistic dam. And do you think this approach is more promising than current methods focusing on like, like linguistic simulation?
Yeah, I honestly, and yeah, honestly, I agree with that. Like, I really think that we don't have a definition of necessarily of what is a certain entity or what is another entity. What is constitutes a cat and what is different from a dog, or what really constitutes a human being. Because there's so many levels there, and like we don't really have a formula for it, so I would think that the best way for us to say whether a artificial system is close to a real one is just it's really but what it can do. If it can do the same thing, then functionally they might be equivalent. Um, but that also you can possibly test all possible things that one entity can do because there are possible infinite possible combinations. So you'll have to somehow there has to be some kind of a test, and I don't know what that is. Even recently with this large language model, people have just started scratching the surface on like all possible. They run all possible tests on these systems and try to figure out what capability they really have and they don't really have. And it's very unclear what what the results are, what you can do, what you cannot do, and at the end of the day, you have to. It's a bit of a trial and error. Mhm. Yeah,
Okay. Like you just
that's
like like you just like keep coming up with some random tasks and you just see if it does well and then, you know,
yes. I mean, more than random task, I guess. It's always like if you want an artificial system, is always to do something. So I guess the idea is you try to make it do what you want and try to make sure that it can do more or less the same thing that a human can. So, for example, autonomous driving, right? Even there, you have infinite number of scenario that you could face while driving a car, right? Whether you're human or artificial, and so you can possibly test all of them. You also can possibly train on all of them. So you have to test on a lot of conditions and see what the problems are and design the system in a way that is fairly generic and he has a bit of common sense like us. Other than that, I'm not sure if one could identify a test that would say, okay, yes, this car is good enough to drive or not. I think we will never have such a test because there's always possible different conditions, right? Like, for example, years ago, I was like driving on the road, and all of a sudden, there was a ladder like blocking my entire lane, right?
a ladder.
And a ladder, yeah, like a ladder that you walk on,
Oh, okay.
and it was like pretty tall. And I mean, first of all, you would have to recognize it, and then you have to figure out what to do. And like my all the lanes nearby were like completely filled with cars, and so I had to decide, okay, should I just brake or should I go over it? And if I go over it, my prediction was, okay, all my tires are gonna pop.
Okay.
So you see, my point is, I ran over it and nothing happened. And the point is, sometimes there's so many different possible cases. One time I was in Baltimore driving on the highway, and some guy jumped off from the other lane and ran through
What?
ran through. I mean, it was just all sort of crazy things can happen on the road. I mean, you could find a crater at some point, a bridge that is interrupted, all sort of things. So, I don't. Can you test all these cases? No, right?
Yeah.
Um, so I'm not sure that there is a for living things that have infinite possible action, infinite possible scenarios in the environment. I don't think there will ever be a test that can test all their capabilities, honestly, just by
Okay.
the sheer number of possibilities.
Yeah, that makes sense. Okay.
But it's the same for you, right? So when you go and take a driving test, what do they test? They test, okay, a little bit of your abilities, but it's just like a tiny subset, 0.01% of what you'll ever encountered even normally, right?
Yeah.
So, and then they say, okay, yeah, you're ready to drive. So I guess artificial system, we usually hold them to a higher standards in
Mhm.
a way, right? Um, which is, good and bad, but that's because we kind of have an idea statistically of what a human can do, on the road, and once you give him a driving license, but we don't have a statistical idea what a machine can do. So the point is you have to test a lot, and at some point you'll have the same kind of statistics and you'll be okay with that, maybe.
Okay.
Yes.
Um, so I saw that you had a Medium blog and you have like lots of blog articles. So I read
Oh,
through some of them. And in one of your articles, you mentioned that transformers are really close to universal neural networks. And it can handle, lots of different types of data, such as vision, text, speech, and so on. So do you think this is close to the final neural network architecture?
yeah, I think some honestly, like at the beginning of neural network, let's say like 10, 15 years ago, right? People were pretty happy by crafting neural network and running it on some data and training it. But it was really hard to scale up and continue to learn different modalities. And I think we spend way too much time like focusing on creating data sets and creating custom neural network for a specific data set. But at the same time, people were looking for like a swift army knife of neural network,
Hmm.
and one such network could be the transformer architecture, which really surprised us. Honestly, just in the last couple of years, of the capabilities that all that they can do and learn when scaled up, even with this very simple learning techniques like predictive learning, right?
Mhm.
So I would say, yeah, that's like a really good. We're scratching the surface a bit on what the real artificial brain could be.
Mhm.
And I think we have to embody it and give it more senses and train multimodal, and then try to figure out what can it learn, right? And we also need to figure out these continual learning capabilities. How much can it continue to learn or learn online? But I think I would say now it's more exciting than 5 years ago. 5 years ago, it looked like we're doing the same things over and over, and now it looks like we have foundational model that can do much, much more. And so it's exciting. I hope, I think by trial and error, we'll keep looking and try to find something that can model our brain. That said, we're still like thousands of time away in terms of efficiency.
Mhm.
The capabilities are getting better, but also, hasn't been really used in robotics as much, and it hasn't really proved in like the physical world.
Okay.
So I think there's still a lot of work to do. It's a never-ending story, I would say.
Yeah, yeah.
But it's exciting times now, yeah.
Okay.
Yeah, that's a good question. Thank you.
Okay, so um in another Medium article that you wrote, you mentioned spiking neural networks, and those tries to like
Yeah.
actually simulate the spiking in real neurons, right? And so
Yeah.
that seems like a step towards like combining more neuroscience to AI.
Yes,
But at the
yes.
same time, like I know that those networks they still rely on back propagation, which is not very neurosciencey realistic. So in the
Yeah.
future, do you expect that AI will continue to like almost look one to one, like real human brain and an AI, or do you think there will still be a combination of like engineering where you just see whatever works and
Yeah. Yeah, I think there's going to be quite a few heuristics, but the bottom line is that artificial system based on silicon are very different from biological neural network, right? So in biological neural network, which are great, I mean, they allow us to do all these things, but they have a fundamental problem, which is electricity doesn't conduct very well in within our body, right? In a physiological solution. And so they can only transmit pulses and over short channels. I mean, some channels are pretty long, like from our brain all the way to the spinal cord is like a meter long, right? Um, but um, but in general, they use this spiking because the problem is, like you need to constantly reconstruct the signal that would dissipate otherwise. But in silicon we can make really good wires, right?
Mhm.
But in biology you can have lots of wires in a very very small area. In silicon we can't. We can only make like a few layers of wires, and the density is very low. So things are different, but I think, and also there's much to learn because in artificial neural network you can do backpropagation over many layers, because you can look at the very small differences across many layers, right? In biology, you can't do that because the noise is so high and you can only go from layer to layer. So I think, in artificial neural network, we still have to learn how to scale up the layer by layer learning.
Okay.
That we don't know. That might be more efficient. I'm not sure. Maybe that's one of the ingredient of efficiency in the brain, um, or maybe it's not. Maybe it turns out that artificial network with backpropagation are much more efficient, or because you propagate the signal very, 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 very easily, and you can train them faster.
Mhm.
I don't know if we know the answer to those questions really. So we'll have to look at it and learn more and try things.
Yeah. I mean, I
Uh,
guess it is.
Also, we're
I guess
stuck.
it is.
Yeah, also like biology stuck with this with his own substrate, biochemical substrate, and we are stuck with right now. We're stuck with the silicon chips, right? Maybe there's another medium that would create better brains, artificial brains, but yeah, that's what we have right now, and so yeah, it's not. We can't answer those questions, I guess, right now.
Yeah.
I
Okay.
think they'll still, yeah, people will still try to investigate these issues.
Okay.
Yeah.
So this interview is like it was
Yeah.
supposed to be like more oriented towards like beginners like in the club.
Yes, yes.
So I wanted to ask you like
Yeah.
you have any advice for students interested in AI?
Oh, absolutely. Yeah. Well, I think honestly, it's a really great time today because of the internet and all the code and example and things that we can share. I think really what a person needs is mostly drive. Like at any level, if you want to learn, there's so much material, but you shouldn't be discouraged, and you have to figure out a way to learn step by step. There's so many courses at so many levels in machine learning that I think anyone can pick it up. One of the issues is, of course, also need to learn programming a little bit.
Mhm.
So I would say, you start with a Python class or something like that, and then you move on to some simple class or simple tutorial machine learning. And then I think the next step is to jump into some nice project that you like.
Mhm.
maybe you see that this ML at Purdue group is really awesome because it allows you to, you know, form a group and learn from each other and do things together, which
Yeah,
can
yeah,
keep you excited and motivated. So I think, yeah, like if you're someone that already joined such a group or similar group anywhere, and you have the passion, you can learn really easily. And honestly, you don't need a university, you don't need a teacher, you don't need a professor. A lot of the stuff you can do on your own, which is it's nice and also scary, and you need a lot of passion. I think that's all. But
yeah,
that's true for everything almost, you know. But there's some things that it's hard to learn. Like I can't learn about nuclear power plant unless I work in one, right? But machine learning, oh gosh, just need a laptop. Yeah.
yeah, yeah,
So it's so much easier, yeah.
yeah. I mean, just watch YouTube videos, I guess.
Yes, those are, oh my God, there's so much knowledge in there, right? That you can learn from really awesome people. And I do it too, you know. I often like listen to lectures and ideas online and people I never met, and
Hmm.
it's really awesome. Yeah, I mean, it's all you need is like some area that you're interested in, and just to try to go deep, deep, solve all the problems, more problems. There's always the problems to solve. So,
Yeah,
and if you don't know, you ask a group, like even a GitHub. There's amazing projects, and you can join them and say what are the problems you're trying to solve and help them out. That's an awesome way to learn. Yeah. And you can do that on your own, on your laptop, anywhere where you are. So it's really great.
yeah,
I like that.
yeah. I mean, on GitHub nowadays, like everything that's trending is just like some AI
Yeah.
model or something. So
Oh yeah, I bet. Yes.
yeah. Okay. My last question. So okay. So I know this you might be a little biased, but like do you think AI is just hype, like blockchain or like NFTs or something?
Yes. Well, AI is hype because I mean, even you and I talk about AI now, but I don't even like the term much because everything that we're doing so far is mostly machine learning. You know, it's like some basic learning algorithm. AI, maybe we're getting more into it now because we have this large foundational model. But I would say AI really starts in when you have like a robot and you're trying to do something in the real world and unconstrained. And yeah, so I think we still need to do it. I think uh, I don't know. I mean, definitely AI would play a role, but AI in the sense of machine learning, neural network, deep learnings. But I think we need to do more work in robotics, you know, and yeah, because we're still behind. So like even with all this algorithm, we don't have good algorithm to be able to grasp any kind of object or navigate in an environment. And there's still we still don't know how to learn all these things. We still don't know how to learn multimodal integration in a robot that you have different sensors.
Mm,
Keep learning and keep training, and so I think that's an area that probably uh, needs to needs to evolve. Um, but yes, if it, you know, if AI or what you want to call it now is going to empower this robot, then I think it'll change the world for sure because we'll have like artificial entities that are, you know, as good as able as us or better, and they could do lots of other things, right, that we cannot do. For example, we could send them to explore the universe because they live forever. They can live forever or they can replicate somewhere else. And maybe we won't even be able to know what they find out because our life is so much shorter, right? And so much constrained by where we live in this planet and where we can reach in the short time we live. Yeah.
yeah. Yeah, I mean, when you were talking about robotics and I was like thinking about those food robots around campus,
Yeah.
and
Yeah. Right.
I'm just gonna see like 10 times more of that or something. Like we're just gonna see like some robots deliver
Yes.
like like I don't know, a refrigerator or something. I don't know.
No, that's right. Yeah, I mean, those things cannot, walk up the stairs or open the door and give things to you. But soon we will be able to do that. So that's great. And I just hope that yeah, we'll be able to program them and make sure that they only work for a good cause.
Yeah, yeah.
Yeah,
Okay.
yes.
Thank you so much for
Thank you
agreeing
for
to
the
this
time.
interview.
Yeah, too.
Okay,
So
so
yeah, it's been a pleasure to talk to you. Yes,
yeah,
and
yeah,
if you need anything, contact me again.
okay, yeah.